Hi guys, welcome back to another video. So we're currently going through the K.A. Stroud Engineering Mathematics book, and we're on part 1, which is the foundations, and then chapter 9, which is trigonometry. We're just about to get into the trig functions, so things should get fun from here. So what we're going to do is we're going to get reading through this next part, and then answer the exercises as well. Let's get started. So ratios between side lengths of one given triangle are also equal to the corresponding ratio between side lengths of a similar triangle. Okay, cool. So let's just remind ourselves of what a similar triangle is, right? Cool. So similar triangles, they can be different sizes, right? Right? But they will have the same shape and they will also have the same angles. So what that means in practicality, let's draw some triangles and we'll just do two there, just differentiate the angle, the triangle, right? So we call this one triangle 1. Now let's take this exact triangle, duplicate it, spin it around so you can't recognize it, make it much smaller. If we label these A, B, C, A, B, C, or let's do A dash, B dash, C dash, right? So obviously you know it now because you saw me duplicate it, but looking at this, it might not be obvious that these two, even though they're not the exact same triangle, they are similar triangles. Why are they similar? Because they have different sizes, same shape, same angles, right? So what this is saying here is that ratios between the side lengths of one given triangle are also equal to the corresponding ratios between side lengths of the similar triangle. So ratio between the side lengths of triangle 1 are also equal to the corresponding ratios between side lengths of triangle 2. So what this is saying here is that AB, AC, A dash B dash, A dash C dash. So what this is saying here is that AB, so these two, right? These two over A dash B dash is equal, same ratio as AC over A dash C dash. So that's fairly straightforward. We covered that in the last lesson. If you're a bit rusty on that, just go over the last lesson and they'll bring you up to speed. That's fine. Cool. The author's just preparing us for the trig functions, so it's good to have a bit of background behind the trig functions. By multiplying both sides of this equation by A dash B dash over AC, we find that, so multiplying both sides of this equation here. So we're multiplying this by A dash B dash over AC, and then again this side here, A dash B dash over AC. So what you find is, so you multiply this side by A dash B dash over AC and this side over A dash B dash over AC. That gives you AB over AC is equal to A dash B dash over A dash C dash. So that the ratio between sides A and B and AC in the smaller triangle is equal to the ratio between the two corresponding sides AB and AC in the larger similar triangle. So now it wants us to work out AB over BC. Pause the video, give it a go yourself, and then we'll go through it together. Cool, so hopefully you gave it a go. So the trick is just in reading the question again. So that the ratio between the sides AB, right, and AC in the smaller triangle is equal to the ratio between the two corresponding sides AB, A dash B dash, and A dash C dash. So this is equal to this. This is what we wrote here, right? AB over AC is equal to AB, AC, but with dashes, right? So when we've got AB over BC, then it obviously is just equal to the ratio of A dash B dash over what? B dash C dash, right? You can see that here. The thing to keep in mind is just remember that we're talking about these triangles. We're talking about triangle 1 and triangle 2 and how the ratios between them, the ratios between this side, or the sides of this triangle, are equal to the ratios on the side of this triangle. Why? Because they're pretty much exactly the same. They're similar. Remember, they have the exact same shape, the exact same angles. They're just different sizes. That's it. Right. So let's carry on. So because AB over A dash B dash is equal to BC over B dash C dash, then multiplying both sides of this equation by A dash B dash over BC, we find that just fine. So this is just explaining again the same process, just to show that they are indeed related. But in case you're wondering how they're coming from, you should know how to do this in terms of multiplying these two together and how you get that, and multiplying these two together and how you get that. It's just a process of elimination, basically. So if you see AB over A dash B dash and A dash B dash here, these two can obviously just be eliminated. And then same thing here, you got BC and BC. These two cancel each other out as well. So that leaves you with AB over BC, which is exactly what you have here. And this leaves you with BC at the bottom, B dash C dash at the bottom, and A dash B dash at the top, which is exactly what you see here, right? So obviously for this part here, it's just going to be again A C dash dash over B dash C dash. Fairly straightforward, which is what you can see there. And then they're going to multiply it again here. So you're going to see A dash C dash cancel each other out. You're going to see BC and BC cancel each other out. That leaves you with AC over BC. Sure, we go there. And this is your B dash C dash at the bottom and A dash C dash at the top, which is what you have there. Cool. Again, this is all just in explanation of basically the trig functions that we have coming, so which we'll do in the next video. So all triangles whose corresponding ratios of side lengths are equal have the same shape. Yep, they are similar triangles because corresponding angles are equal. Right, that makes sense. Again, going back to here, think about it, right? This angle here is going to be equal to the corresponding angle in this triangle. Where's that corresponding angle? I'll give you a second. Here, right? Think about it. So here you got A, here you got C. The angle between A and C here is going to be equal to the angle of A dash and C dash. Right? These are going to be the exact same angle, right? And the exact same thing for this angle here and this angle here. And obviously, you know that this 90 degrees right angle and this 90 degrees right angle are obviously both 90 degrees. Again, most of this stuff, I mean, you've probably already know it intuitively just from dealing with angles from when you was much younger, but it's important to keep in mind. So they are similar triangles because corresponding angles are equal. Very important point to remember. Corresponding angles are equal. Consequently, whilst the lengths of the sides of a triangle dictate the size, right? So the length of a side dictates the size. The ratios of the side lengths dictate the shape. So it's fairly obvious. So if I've got this triangle here versus this triangle here, one is much longer than the other, right? And in terms of how these, if I take this triangle here, right, and then I say, okay, I'm going to double it in size, then obviously the ratio, if you said it was a 2-to-1 ratio times 2, it'd be exactly the same shape because this ratio of this side here is half of this side. This side is half of this side, etc., etc. So again, fairly all intuitive stuff, but stuff to keep in mind. The angles of the triangle. Yep. Because we need to know the properties of similar triangles, we shall now link these ratios of side lengths to specific angles by using a right angle triangle. The ratios are then called the trigonometric ratios. And so now we move on to the fun stuff. Cool. So we'll jump onto those in the next video. If you enjoyed this video, give it a like. Again, like I said, all these notes will be found in the description box below, and I shall see you guys in the next one. Peace.